Hello everybody, welcome into another lesson. Today we are going to talk about linear functions. So, what are linear functions? Of course, they are a function of, you have y being a function of x, and this right here, y equals x, this is the mother function. So remember, y equals x is the mother function. Maybe you found a new cuss word. Instead of saying a bad word, you could say mother function. But so you have y equals x, which means y is equal to x to the first power. In linear functions, y is always a function of x to the first power. So you may see y equals x, you may see y equals some coefficient with x, like 3x or some other coefficient like 4x, 2x, what have you. You may see y equals x plus a constant. That's still a linear function. X minus a constant. You may see both a coefficient with the x and a plus or a minus a constant. You may even see the coefficient of the x term having a decimal or a fraction. You could have negative numbers. You may even see you may see it backwards. You could see the coefficient minus the x term. You also may see it written as x plus y or x minus y equals some constant, or some coefficients with the x's and y's equaling a constant. Either way, these are all linear functions. X is always to the first power whenever we have a linear function, and it's y is always the function of x. So why is it called linear though? Simply put, the graph of a linear function is, well, a line. So you could take the part of the name for line. That's what you get for a linear function. You get a graph of a line. So we're going to go ahead, we're going to graph some of these linear functions, okay? So let me go ahead over here. I'm going to make my coordinate plane. Let's make my coordinate plane here, alright? Let's just do that. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I got my coordinate plane here, the x and the y axis. Now, I'm going to set up some equations here. So to start with, we have y equals x plus 2. Being a linear function, we want to graph that. We know it's linear because x is to the first power. We just happen to have it's plus some constant of 2. Usually what you want to have is you want to have 3 points to be able to sufficiently draw the line. So pick any value for x. You're going to find 3 values for x that'll generate 3 values of y. Let's see. We'll do y equals, we'll put 0 in for x. Y equals 0 plus 2, which happens to mean y equals 2. So therefore you'll get the point x being 0, y equaling 2. You'll get the point 0, 2. Okay. How about we could do y when x equals 1. So when x equals 1, we'll put that in for x. So you'll have 1 plus 2, which means 1 plus 2 is 3. Y equals 3. So when x is 1, y equals 3. You'll get the point 1, 3. So 1, 3. Okay. Let's do one more. Let's do when y equals -1. So we'll put -1 in for x. You'll get -1 plus 2. Well, -1 plus 2 is +1. So you'll get y equals 1. So when x is -1, you'll get +1. So you'll get the point -1, 1. Okay? So again, for the first ordered pair, I made x equal to 0. When I made x equal to 0, y was equal to 2. So we got the ordered pair 0, 2. When I made x equal to 1, I got the y coordinate being 3, so I got the ordered pair 1, 3. When I made x equal to -1, I got the y coordinate of 1, so I got the ordered pair -1, 1. So now once you got your points, you're just going to go ahead and connect them and draw the line. We'll go ahead, connect them, draw the line, and voila, you got yourself a nice line through those 3 points, and they just keep going infinitely. They keep on going infinitely. So yes, that's how you would graph these type of equations. Alright, let's do another. Let's go up a little more. There we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright. So I got my coordinate plane drawn. Now we're going to graph another function of y, another function of y being a function of x. So this time we have y equals x plus 5. So we want to graph y equals x plus 5. Well, I'm going to pick some different points this time. What if I pick x being -5? So if I make x -5, I'll put that in for where x is. We'll have -5 plus 5. Well, -5 plus 5 is 0. Y would be equal to 0. So when I make x equal to -5, y is 0, I'll have the point -5, 0, which would be right here. -5, 0. Alright. Let's say I make y equal to, I'll make it -2. So when y is -2, I put that, y being -2, x being -2, I'll put that in for where x is. You'll get -2 plus 5. Well, -2 plus 5 is +3, so that'd be +3. So when x is -2, y is +3. So I'll get the point -2, 3 right here. And then last but not least, why don't we make x be equal to 0? So we'll have 0 in for x plus 5. Well, 0 plus 5 is in fact 5. So when we have x equal to 0, we get y being 5. We come up with the point 0.5. Okay, 3 points are usually sufficient. You can do more than 3 points if you like, but I think 3 is sufficient. So we'll go ahead, we'll draw this wonderful line here. And you get a nice line there through those points that we drawn out. So those points, and when you just connect them, help to form your line. That's all. That's why we usually like to have about 3 points to make it nice. Alright. Let me draw another coordinate plane here. draw another nice coordinate plane. Okay, we'll do that. See, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, got my coordinate plane drawn. This time we're going to do y equals x minus 4. So y equals x minus 4 is the function we're trying to graph. So again, you can pick any random values for x that you like, okay? Pick any random values. I'm going to start with 0. So when x equals 0, we'll put in that value for x. You'll have 0 minus 4. Well, 0 minus 4 happens to equal negative 4. So when x equals 0, y equals negative 4, you'll get the point 0, negative 4, which will be down here. Alright, why don't we make, let's do x equal to 2. So when y equals 2, when x equals 2, we'll put that in for x, we'll have y equal to 2 minus 4. 2 minus 4 is negative 2. So when x equals 2, y is negative 2. So we'll plot the 2, negative 2 right here. And then, last but not least, let's make x equal to 4. So y would equal 4 minus 4, which 4 minus 4 is 0. So when x is 4, y is 0. So that's going to go right here. It's not perfectly linear, is it? I may not have drawn this the straightest, I apologize, but done the best I can. So when you connect through the ordered pairs where they're plotted on the coordinate plane, this is what your line will look like. All right. How about, let's do another one here. Draw my coordinate plane again. Alright, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I think that'll work. So there's our coordinate plane. Now let's go ahead. Let's see. We got y equals negative x minus 6. This time we have negative x minus 6. We're going to graph that. So once again, we'll go ahead. We'll pick some values of x. When we put in, let's do 0 for x. So you'd have negative 0 minus 6. Well, negative 0 is equal to 0 minus 6. Which is just equal to negative 6. So therefore, when x is equal to 0, y equals negative 6. So we can plot that point down here. There's 0, negative 6 plotted. Alright, let's do y equal to Yeah, see, negative 6 would be about out here. Let's do x equal to negative 6. So we'll do negative of negative 6 because we're putting negative 6 in for the x. You'll have negative of negative 6 minus x. Well, negative of negative 6 is positive 6. That'd just be 6 minus 6, which would be equal to 0. So when x is equal to negative 6, y is equal to 0. So we'll plot that point right here. Alright, we need to find one more point, I would say, to make this sufficient. Let's do negative 3. So y would equal negative, and then we'll put in negative 3 for x, minus 6. Well, negative of negative 3 equals positive 3 minus 6. 3 minus 6 is negative 3. So when x is negative 3, y is also negative 3. So negative 3, 3 would be right about there. Now we're just going to draw... Nah, that's not a very good line. It shouldn't be crooked like that. I'm going to have to come around the other side and draw it because I'm getting myself all mixed up here. Well, it would be, man, if I can draw today. When I have to turn around and do it the other way, it's a little bit harder for me. So, yeah, here we go. Notice when you put a negative in front of the x, it reflects the line in the y-axis. It turns it the other way. It makes it almost like a mirror image when you put a negative in front of the x. But that's what the line would look like running through those points. But later studies will talk more about what those coefficients mean. You don't need to know about reflections and stuff right now. You just simply need to know how to graph them. But yeah, changing the sign on the x can actually really alter what the graph looks like. Okay. I have here 4 more examples. So let me draw my coordinate plane again. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so I drew my coordinate plane. This time we are going to do the equation y equals negative 2x plus 2. So suddenly we have a coefficient on the x. We have a negative 2. Well, like you would any other equation, you're just going to pick some value for x. Why not start with 0? That'd be a good one. We'll let x equal 0, so you'll have negative 2 times 0 plus 2, because x is 0. Well, negative 2 times 0, that's just 0, so you'll end up with 0 plus 2. So that means y equals 2. So when x equals 0, y equals 2. So we got the point 0, 2. We can graph that right here, 0, 2. Alright, let's pick y. Let's set y equal to, this time having x being negative 1. So we'll have negative 2 times negative 1 plus 2. Well, negative 2 times negative 1 is positive 2, so you'll have 2 plus 2, which means y is equal to 4. So when x equals negative 1, y is going to equal positive 4. So negative 1, 4 hangs out right there. Alright, and then last but not least, we'll set y equal to, we'll have x rather equal to positive 1. So we'll have negative 2 times positive 1 plus 2. Well, negative 2 times positive 1, that's negative 2 plus 2. Negative 2 plus 2 is 0. So when x equals 1, y equals 0. So 1, 0 is right here. Now we just draw a nice line through these 3 points here. Now, since we have a negative coefficient, the line's still tilted the other way, but that coefficient of 2 increases the steepness of the line. You notice it's a steeper line whenever you tack on a coefficient. A whole number coefficient anyway. If we had a fraction coefficient, that would decrease. That would if it was a fraction that was less than 1, it would decrease the steepness of the line. But you can get some really interesting lines here. By doing these. Alright, 3 more. Alright, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Alright. There's the coordinate plane for this problem. Alright, so we got y equals 3x minus 4. So we're going to graph y equals 3x minus 4. Again, pick any random any value for the variables of x. I'm going to start with 0 again. I like to start with 0. So we're going to do 3 times 0, since we have x equal to 0, minus 4. Well, 3 times 0 is 0. So you have 0 minus 4, which would equal negative 4. So y equals negative 4. So when x is 0, y is negative 4. You get the ordered pair 0, negative 4, which would be right here. Okay, how about this time we do x equal to 1. So we'll set x equal to 1, y equals 3 times 1 minus 4. Well, 3 times 1 is 3. You'll have y equal to 3 minus 4. 3 minus 4 is negative 1. So that means when x equals 1, y equals negative 1. Therefore, you get the ordered pair 1, negative 1, which would be sitting right here. And for good measure, why don't we do x equal to 2? So we'll set y equal to 3 times 2 minus 4. Well, 3 times 2 is 6. You'll have 6 minus 4, which we know is equal to 2. So when x equals 2, y equals 2. Therefore, we get the ordered pair 2, 2. Alright, now you just draw a nice line through this. Just connect the dots. Connect your dots, and you get a nice line. So you get, this is what 3x minus 4 looks like as a graph of a nice line. Yeah, I don't think we need to do more examples. I think we got it here. I don't need to make this a super long lesson, but so we've seen linear functions. Again, that's just x to the first power, and they're called linear because you get a line. You just get a straight line. That's all you get. And then to graph your points, to plot your points and graph them, you want to find no less than 3 points by plugging in some value for x in your function, and then you'll get out some value of y, and whatever value of y you get at that value of x, that's your ordered pair. You plot those points and just connect the dots, you should have a nice line. So that's it for this lesson. The very next lesson, we are going to talk about what those coefficients on the x term means in these linear functions, which is known as the slope. We're going to talk about what the slope of a line is. So I hope everyone has a good night. Take care.